Folks, good morning, good evening, everyone. Can you all hear me?
Yep.
Yes, we can hear you.
Yep.
Yeah, I can hear.
Excellent. Thank you. So let's just wait a few minutes as people trickle in. And I believe, Steve, you're here from
Yes.
Perfect. Thank you. I know it's probably very, very late. So, we'll
Yeah,
try
that's
to
Sorry,
Steve.
wrong Steve, Harry. Apologies, it was me.
No problem, Stephen. So just appreciate you staying this late, and we'll try to get to it as soon as possible. Thank you.
Can you hear me okay?
Loud and clear.
Okay, very good.
So just wait the next minute or so.
Okay.
So I guess, Stephen, I'll call you Stephen, I guess, to differentiate. So, Stephen, do you think we should get started?
Yeah, I think we've waited long enough. I think it's good.
Yeah, I think so as well. So I guess Happy New Year to everyone, and welcome to the first session of this new year of Rack and Power. And so we have lots going on here. In terms of the high power offerings, in addition to on the rack side as well, and control and AI driving the power even higher. So to kick the session off, we have Steve from Cheval, if I'm pronouncing it correct, and he will be presenting on the knockdown version of the OCP rack. So without further ado, Steve, you can share your screen and get started.
Okay. Go ahead and do that.
Can I please request everyone to go on mute, please, to avoid disruption and be respectful to our participants. Thank you.
Okay. Can you see my screen okay?
So we just see your name right now, but nothing else at this point.
I did share screen and I'm showing that's what I have to do, right? I click share screen.
I'm just gonna see if you have.
Oh, okay, hold it. I see. Moment, I see.
Yeah, there you are.
Okay, I think we should be good. And let me come here to full screen. Okay, is that all right? Can you see the screen now?
Yeah, it's perfect. Thank you.
Okay, all right, very good. Thank you very much, everyone, for inviting me here, allowing me the chance to speak. So it's a good morning, afternoon, evening, depending where you're at. So our company, the Cheval Group, we're a multinational joint venture. We've been in the data center business over 35 years. We do a lot of OEM, ODM work with IT firms, and mostly with EIA and OCP racks. We joined the OCP in 2014. And over the past 20 years or so, we've shipped over 1 million racks with about 0 shipping damage, no assembly issues, no quality problems. These are all knockdown racks. So we have some good experience, I think, in the knockdown format, and we decided to apply that to the OCP concept. All right. And the reasons we did this, the project was to create a knockdown version of the ORV3, primarily to reduce the cost, reduce the shipping cost, reduce the storage cost for handling the racks. We also wanted to, we have to maintain or exceed the OCP design requirements. The assembly process had to be fast and simple, resulting in a lower total cost of ownership for the user. And of course, we continue to look for feedback from the open community for future improvements. And in terms of the improved shipping cost of the savings and the cost, we estimate you can roughly get about 65% savings in the shipping. And that is coming from the format, of course. The picture on the left here is showing the typical assembled or welded frame version of the ORV3 on a pallet. And then on the right-hand side is a photograph of what the flat pack system would look like. So quite simply, loading into a container, we can get about 27 units of the assembled version and up to about 90 different, about 90 sets of the flat pack version. So that gives you about a 3-to-1 ratio, which with the shipping cost being high, storage costs being high, this is a major incentive. And then, of course, there's a little bit lower cost on the product itself because the process cost on our side is lower. So what we've done here is I've noted down what the specifications are. The top row are specifications, requirements, and these are because the numbers kind of vary a bit depending on which specific model you're looking at. So, for example, the static load requirement for the based on the unpackaged test is 1,400 kilos. This one is from the MetaFrame V3 requirement from July of last year, and then we have a dynamic load or rolling movement of 1,000 kilos. That number is coming from the Google implementation of the V3 from 2022. So our own product, after we have done the various tests on it, for the we have both a knockdown version and we have a welded frame version. And you can see on the table here, in fact, both versions, knockdown and the welded, we got 1,600 kg for the static load.
Not back. No.
And 1,400 kg for the dynamic test. So we're able to, in these cases.
Want me to, after this Zoom call, no way.
I'm sorry.
No, I apologize. I don't know who is. Stephen, are you able to help me? I'm trying to see as well who is not on mute, and this is really causing a lot of.
Yeah, I'll have a look as well.
Jason M, I think.
It's Jason
Okay.
M. If Jason M could please mute. He's just muted. I think that's everybody. Yeah, you may continue, Steve. Sorry about that.
Okay, no problem. So we've been able to exceed the requirements in both cases, and the tests that we have done there in the table right here below. These are taken from the OCP standard, the rolling movement and the unpack test. The rolling movement, you've got various an obstacle to roll over. There's a gap test that must be passed. There's a ramp test, the roll-off test, and then the rack distance rolling test. So we conducted these in our facility, as well as on the right-hand side of the screen here, the unpackaged test. These are when the rack is loaded up. In both cases, the rack is populated with dummy weights to match the table on the top. and then we run through these tests here. So these are the summaries of the tests that we did. And then here we can see this is the top level summary. Apologize for the misspelling on the second one. That should be GAP test, not GAB test. But this is pulled from the total report. And on the right-hand side is actually a photograph of the unit we were testing with the dummy weights loaded in there, equally distributed throughout the rack. This is in our facility in Thailand. So we did not encounter any issues with this. We conducted a few other tests beyond this, but we're only publishing the tests as required by the OCP. And then in addition to the loading test, one of the other concerns for a knockdown version is going to be ground continuity, but because you've got various components in the frame separated, not welded together. So we do a ground continuity test. These tests are derived from the UL 2416 short circuit test for ground continuity, section 7.14. So we use this, we measure, we assemble the rack, and we take measurements on all the various components. And these are the actual measurements that we take. We do these tests on all the racks that we assemble, not just this ORV3, but we assemble racks on a daily basis in our facility, and they're all subject to the same test. So we applied them here as well. Now here we have a look at the basic components of the rack itself as we have produced it. And you can see on the left-hand side is the basic bill of material. You've got the top and the bottom. You've got the vertical members. We have the cable trays, and then we've also included in the horizontal supports as well. So on the right-hand side, you see when it's all assembled. So now this is how the unit is actually packed in that crate. One crate has one complete unit. So this would be a single pack, and it's a very heavy duty cardboard type on a simple wooden pallet. And you can see how this is showing the components being nested in. They are protected. They're not just put in here like this. They're wrapped in foam sheeting or plastic sheeting, whichever the case needs to be there. And so you can see from the size of this, if you were to do your own calculation, you would see that you could actually get more into the container than the number I specified, but we tend to limit the packaging, the stacking to about 5 high. You could actually get 7 high in a standard container. For the assembled rack or the welded frame rack, because of the height, you generally have to use a high Q container, whereas this one here can be put into a standard 40-foot container. And as I mentioned earlier on, with the ratio of 3-to-1, based on a standard container from Thailand to San Francisco, let's say, that's about a $200 per rack savings on the freight. It would be about $300 per unit, and with this flat pack, you can get it down to just about $100 each. Now, this is the actual quick summary of the assembly process itself. And there is a video, which I share the link at the end of the presentation. There's a video to the actual team assembling it. And quite simply, It only takes several steps. We've used 3 people to put this together for this process, 3 operators in about 25 minutes. And that's going slow. That's not trying to hurry up. That's not in a purpose set up, not in a purposely designed setup. What I mean is for our regular rack assembly, we have a purpose-built line with various equipments to expedite the process. For this simulation, we just did it on the floor, basically, to get kind of a conservative speed. So it starts out, you have the top and the bottom, and then you begin by attaching 2 of the vertical members, or 4 of the vertical members on it to get the basic structure. After that, then you add on the additional vertical support members here. Then you add on the casters and the leveling feet, and then you add in the cable channels, the left and the right cable channels, because as we know, they're now separate components from the main frame. And then after that, assuming you're going to, and I guess from you could probably even avoid these components if you wanted to, they're for additional strength, the horizontal braces, and then we even include the bus bar in here as well, put the whole thing together. And this is a simulation of when it's finished, assembled fully assembled on the left-hand side. And then we have just a couple other images. I just threw them in here to show the same rack with the small side panels, and then another one showing some of the seismic braces. So I've added a QR link that'll take you to the video where you can actually watch our people assembling it. As I said, there were 3 people doing it. It clocked about less than 25 minutes. And this is as I said, this is a conservative time frame. It certainly would take less than that if you were to set up an assembly line, a pretty basic system. You don't need a whole lot. We do not require special jigs to do the assembly process. It's kind of self-aligning. You don't need any really special tools. The hardware is mostly standard Torx or, bolts. You don't need anything special there. And then we'll do a simple, at the end of the process to verify the alignment, we have a simple go, no-go type jig. So that's what we developed, and we welcome any comments or questions about it, either now or you can contact me at any time. And as I mentioned, we've worked on this knockdown concept for well over 30 years for all of our different products that we make. So we're fairly confident that it can be applied here. And case by case, I mean, depending on your load requirements, I think it could be an interesting option. You do a bit more research into your time requirements on your side to put it together, and then that way you can work out your own total cost of ownership.
Question?
So, yes, please.
Is this a product that I would find on your website with specifications and how to order it?
Yes, it's on our website. On the very first page, you can see our website there, and the link would be into our product section and then into the OCP. There's nothing talking about ordering it there. You would just send an email to us, or you can email me directly, because I'm the contact person for this. So I don't know if my email is shared with everyone here or not, but it's steve@chevalgrp.com.
Yep, it is.
Okay.
It is there. Yeah.
Okay. Yeah. So you could just contact me, and I'll send you data sheets and further drawings, whatever you need. And of course, we offer customization as well, because everyone's going to want their own little tweaks to it. So we're happy to do that as well.
You show two different tops, it looks like in this picture, with different size holes in the rear. I assume that's a customization option or something.
Yeah, that's right. That's the cable. That's the cable tray. We've done various versions already, and on the left is a picture. On the right are just 3D renderings. So that's, but they were from different clients. Yes, you're correct. And this is showing what we call the mini side panel that fits into the space between the verticals. They also have a large side panel which covers the entire side instead of this one. You can also see, I think many of these are shown on the OCP marketplace. I think many of these are there as well. But again, I'm happy to share all that with you if you send me an email.
Steve, I've got a couple of questions about the testing.
Okay.
So I may have missed it. Did you say that all the testing you did was ship loadable?
What we have ship loadable, can you what do you mean ship loadable? Sorry.
So for example, did you do the testing where the rack was holding 1,400 kilos, for example, and then you did the tests I think you showed in your slides? Did it have the payload in it?
Yes, right there. We did not. Okay, that's very good. We do not do the shock pallet testing yet. This is the actual image from the test right here. This is the 1,600 kilos in it, and we have a rig at our company that we use. Now the shock pallet, we're actually developing one right now, because what we typically do, well, these are knockdown, so there's no shock pallet, right? And we don't have a facility in Thailand that can do vibration testing on something this large. So we're in the process of developing a shock pallet, and we may link up with somebody. In the past, we've worked with Met Labs over there in California. We've worked with them in the past for some seismic testing.
Okay, so it sounds like you've got to get through shock and vibe, and also like shipping impact testing and things like that yet with this rack, with that payload. Is that right? That's
correct. We've not done the ISTA or the vibration testing yet. So because that's a separate step. Again, this is the knockdown section, and we don't do integration over here, right? Most of the integration is done by our clients, and there are different kind of shock. People maybe have their own shock pallet.
Agreed. Or you're just statically loading it at the data center rather than even having it as ship loadable, for example.
Right. Because that defeats the whole purpose of the knockdown. But since you asked the question, yes, it's also possible to have them shipped on a shock pallet, and then you keep it on the pallet, do your integration, and then it goes out. But you can do that after you get it as well. So
yeah, it just needs the testing done for that to verify. Yeah, okay.
Correct.
Yeah, this is Ben Tsai with Dell, and I would say one of our consumption models is just that, right? We would have racks come in empty, perform the rack and stack integration for our end customer, validate it, and then send the whole thing, over truck to their deployment site. So that is a viable thing, and we would be very interested in seeing how well this product performs in a ship loadable configuration.
Yeah, I think so. Like I said, we have not set the plan up to do that testing yet, and part of it does relate to the equipment that you're going to install in the rack as well, right? But we can certainly cooperate to develop something. I think if you want to pursue that, no problem.
Yeah, thank you. I guess another question, since I have the mic, is you show the seismic braces. Is that again to, let's say, a NEB zone 4?
These are the braces from the OCP site itself. Okay, we've just prototyped them. We've not done the testing on that yet. that's a whole nother step. And obviously there's expense involved there. That again will depend on, you know, the end user requirements. Not everyone's going to require the product be tested to that. And while we have other NEBS racks, we have not tested the OCP rack under the NEBS conditions.
I have a quick question, or should I just ask it now?
Yeah, that's
It's
fine.
okay with
Yeah.
me.
Yeah,
Oh,
please
okay.
go ahead.
I just
Please go ahead.
to follow up, Steve, just wondered, are these rated for a particular level earthquake or seismicity, or is that not, you know, part of the testing to say it's up to this amount or whatever?
No, these are not rated yet, Gene. We haven't tested these yet.
Okay.
And again, that would depend on the particular end user, and they
Sure.
would have to specify what they want.
Right.
You know, the maximum is the zone 4, right? And that we would, I'm not sure that, well, to do both, it could be done, right? I'm not sure that we have not tested any of our knockdown racks under seismic conditions in the past.
Can I just
we
add one helpful point, because I have to go anyway, but my understanding, and we're talking about OCP and openness and all that UC Berkeley and UCSB may have a facility and might welcome the opportunity to test it for you. So.
Interesting.
They have shake. I mean, I've seen them on videos. I think Berkeley might be particularly open to it because they do a lot of that sort of thing. And they're I don't know if you would call their geological engineering group, but you know, they're a university. It might be something they could handle. So it's not the official test. I'm just saying that they may have some expertise that could be helpful.
Well, that's another point too, because not everyone requires a certification. Some people just want to know that you've actually tested it.
Right.
And I mean, in our facility, we can do a static simulation in the NEBS testing. There is a static portion of that where you simulate a side pull. So we can do that, but obviously we don't have a shaker table in our facility. That's a highly specialized piece of equipment.
Sure, and that's why I mentioned, who knows, but maybe Berkeley or UCSD or UCSB might be able to help there, and also their students would get some you know, experience. And just a thought.
Interesting.
Just
I'll send you a message.
Okay. Sorry, I have to go soon, but I wanted to get that in. So.
Okay.
Okay, great. Thanks.
Another quick question.
Yes, please.
I pulled it up on your website, and it says compliant to or conforms to the OCP Open Rack V3 release 0.2 specification. And so I just wanted to test that. Is it? I don't recall what changed from 0.2 to the final 1.0 release, but is there anything that I should be concerned about there?
I don't think so. We can review any particular details. As I mentioned earlier, if I refer back to, let me see, here, this table here, the static load unpackaged test 1,400 kg, that is coming from the MetaFrame V3 spec from July 2023. Okay, that number there. And then for the dynamic loading test, 1,000 kilos, that one we pulled from the Google implementation V3, and that is from September 2022. I believe in the OCP, there is a spec from revision 0.1 from 2019, and I think that was 1,600, but I'm not. I mean, I can't really comment between that and you know why it's changed or anything. But be that as it may, given that there are different requirements, we're willing to work with anyone to, if you have particular tests that you want done, then of course we'll try to work that into it as well.
If I recall correctly from the videos, that Rital, I think, dropped it from 1,600 to 1,400 because during the 10-degree test, I think they were having shelves pop out at 1600, if I remember correctly.
It's that and the front impacts. So the 1 millimeter per second front impact, the equipment was ejecting at 1600 kilos.
Yeah.
That's on the ISTA testing, I guess, right?
That's right. Yes.
Okay. Yeah, we haven't done that part of it yet. We don't have that kind of facility here. As I mentioned, we have to send somewhere else for that. And then you're going to be on a shock pallet when you do that too. So that's a step we haven't taken. But I'm a little bit curious. What I always like to ask people, how much weight do you put in one of these racks as well? That kind of varies as well. So we spec it out to 14 or 1600 kg. I'm always curious how much actually gets put in.
It's definitely over 2,000 pounds. So,
okay, yeah, so that's well within the limit here. Yeah,
well, 2,000 pounds, not kilos. So it's
yeah,
over
2,000 pounds. Because I mean, we just.
Sorry, go on.
No, I'm sorry. Go ahead. I just had a side comment.
I know that we from people we've dealt with, it's been not necessarily on the limit of 1,400 kilos, but it's getting up there definitely with all the cooling equipment and things that's now going in there.
Yeah.
Yeah. So yeah.
That front impact test and the 10-degree tilt test under load are definitely super interesting to me personally, because those are challenging tests.
Yeah, that's for sure. I mean, our some of our standard 19-inch racks, they've gone through that testing, either by ourselves or generally by our partners or by our partner companies, and yeah, they're up to 1,300, 1,400 kilos for that.
And those are knockdown racks like this one.
Correct, but they're 19-inch EIA standard. They aren't OCP. And we just qualified a new rack of ours, a 19-inch rack at 2,000 kilos. We just got the UL cert on that last week, but that's neither here nor there. So yeah, I'm definitely interested to participate further with other requirements for testing. Happy to look at that.
I have a concern as it relates to for the knockdown version of the OCP rack that has the vertical bus bar that goes up the back side. And I think a couple pages up we can see that. And one of the there you go. Down one. Oop.
There it is right there. That
yeah,
one right
that
there.
Bus bar has to be accurately located left to right because of the nature of the first mate, second mate, as well as how rigidly the devices are, or the servers would be in the rack or the power supply unit. As those mate, the connector that mates to that vertical bus bar has a significantly tight tolerance, so that the first mate, second mate, and the grounding clip that's on that connector is located correctly. And often there'll be a fixture that holds that vertical bus bar in place, or is used when it's mounted, as we'd see in detail E here. So I'm concerned about the left-right placement of the vertical bus bar, like you'd see in detail E, that that mating piece for not only the servers but the power supply would be lined up.
Okay. Is that component you're talking about, is that used all the time, just for transportation? You mentioned like a stabilizing, it sounded like a stabilizing component or a bar. Is that what you were talking about?
Well, in the as welded assembled part, there may not be a need for that, but on the put it together, make it yourself one, the the knockdown shipped one, where that bus bar would be a independent piece and would be screwed in like we see here in detail 8. I would almost require that there be a cross brace that's put in there, if for nothing other than to make sure that it's located correctly left to right, so that the first and second mate will work. And also, when you plug a server or the power supply unit in, that the connector that's on each of those mates correctly front to back as well as left to right. Because those servers have, because they're on door slides, they have some slop available, which works to your advantage and sometimes works to your disadvantage.
So your concern is that the bus bar would not stay vertical in the right position then. I don't have all the drawings here. If I recollect, on the top, there are 2 slots into the top frame where the top of the bus bar goes in, and then there's additional, I think there are 3 screws that hold it in place. But I'm not an engineer, I'm sorry to say, so I can't comment completely on your concern. I think I understand it. But if it's certainly additional bracing could be added in there. I don't see a problem with that if there's, if it would prove to be as you fear.
It's just a concern, having seen how the racks are mounted, or the bus bars mounted in the rack, and the tight tolerance that there is left to right. So just something to be aware of for customer assembly.
Another question, if I may?
Yeah.
Does the racks have the features to attach the liquid cooling manifolds that are part of ORV3? Those, I don't know if those were, defined at 0.2. That's really kind of why I asked. But
yeah. In this particular design here, there's no feature to mount the manifolds. We're working with people now, and we've done a whole series of racks with cooling manifolds mounted in there, the cooling manifold and the bus bar. We've developed brackets to locate those precisely where they want them. I'm not familiar too much with manifolds prior to this project that we did, but I understand also that not all manifolds are the same. So what we did in the case that I'm referring to is working with the manifold that the client specified. We then developed together a bracket, a couple brackets to mount it into the rack so that it lined up just as they wanted it. So there is nothing inherently built into this one. I don't know offhand if the spec puts something in there or not. If it does, then certainly we can add it. Certainly it would be in here. But I think depending on the particular model of the brand that you're using, you might need to have a different solution. So that's how we can deal with that.
okay. Can you comment at all on like the number of these units that you've shipped to date?
This is still very developmental, and it's not been a large number. I can't share too much with that, but let's just say it's moving in the right direction. I think I can say that.
So you've got engagement from customers, and you're doing customizations, and you have plans for shipping.
Yes, we have. Well, we have a lot of work going on right now. Not necessarily shipping product. There's a lot of discussion on finalizing the requirements and getting the design just right, because this is still relatively new, and as previously we mentioned about the shock pallets and the testing. There's also some discussion on that going on. We refer back to our other work with the EIA racks, and they're 99% are knocked down, and they're, you know, we make them for large firms that everyone knows, and they're rated to 1400 kg. There's no issues with that. In fact, I think in some ways this OCP, the ORV3 rack, is less complex than the EIA rack. There are less components. We don't have doors. We don't have other things to worry about that have to line up. So we're confident that this concept is quite suitable, right? And as I said, we have some engagement going on right now.
The pictures show what looks like a single bus bar, but the web page says there are 2 power zones with 230 OU power areas.
Yeah, this is just the one I put together for the presentation. I'm not sure exactly how the other one would be set up. I'm sorry, I can't comment on that too much. I just prepared this one here. I just want to do the basic setup first to kind of show how it would work. But I think that in theory, I believe we can put 3 bus bars in here. Now, as far as I know, this particular one, as we can see from this detail E, we only had, this is an embossed point on the bottom frame to seat the bus bar. We've only got one of those built in here right now. Although I know you can put, from the spec, you can put 3 across the back, as far as I understand. We have not had a request to do that, just one so far.
The power zones, I think, is referring to a vertical partitioning of the bus bar, not, I mean.
No, that would, okay, yeah, sorry. That might be right around this area here, I think. Yeah, you can separate, I've seen that separated in the front, also with split doors and things as well. So, but I don't know how that works. I'm sorry, how it connects to the bus bar. I'm just not familiar with that. I'm sorry.
Right, okay. Static load. And the other thing I would point out is your web page has different load testing data than what you presented here. The web page says, yeah, it's dynamic load of 1,000 kilograms, not 1,400.
It's yeah, we had a problem last week. Someone hacked our website, and I think they thank you for telling me that. I haven't had a chance to check it. I think they put up the wrong data. I didn't have a chance to check it before this meeting, but I'll look at it tomorrow when I get in. Thank you very much. But this is the correct data here. And this is the newest information. That is probably something from a previous test or a previous version, I think.
Yeah, I think a lot of the material on the website actually, even though it's linked from the ORV3 link, it seems to refer to ORV2 specs for some of the documentation there.
Yeah, like I said, we got hacked last week and they tore down the site. I apologize to everyone for that. I'm sorry. It should be up to date. I'll get that fixed so you can access it. It was one of those things.
So I have one quick question, if I may. What's the tolerance, the build tolerance or the accuracy tolerance once the sort of manually constructed version is put together compared to the sort of manufactured welded version? Is there a significant difference in the tolerances for fit and accuracy of placement of things?
No, it's going to be pretty much the same. Otherwise, the equipment won't fit in there. So no, we have to maintain the same tolerances, whether it's the welded version or this knockdown version here. I did not show it, but when we do the testing, what we've got here are just the just the top level results. Okay. But what they do is they'll take measurements, multiple measurements from in the front and the rear on the side, before and after the test. That data is not here, but we check all that. And between the welded frame and the knockdown frame, there's no real difference. It's especially on, well, I can refer to the EIA racks as well, because there you have quite tight tolerance between the rails, and those have to be very precise. So this one is a little bit bigger than that, and you're not using the 19-inch rails quite as severely. So it's a little bit looser. But no, between the two, it's the same. In fact, the welded frame is probably a bit more difficult because you've got one large piece to control during the process, and you have many factors that can affect the dimensions during the manufacturing process. So in some ways, the knockdown version is easier in some ways, but it's a question of how you develop your manufacturing process. So we've had.
I think my concern would be is kind of the stack up of tolerances as you build. If your multiple components all have some tolerance, if you get them all on the wrong side of the tolerance band, you end up with something which may end up being out of tolerance. But if that's been something you've tested, that'd be a good reassurance.
Yes, of course, you're right. Yeah. So I mean, very simply, you check. We check at multiple points, significantly the top, the middle, and the bottom, right? And then other points too. I didn't put that data on here, but we do a very thorough check, diagonal checks from the frame side and also from the front. And we also have other functional tests. It's not shown on here again, but there'll be another test where after the load tests are done, we have a sliding tray, right, which has to continue to engage in and out after the test, which is an indicator of any distortion in the frame itself. So there's no significant difference between the two. At the end of the day, you have to pass the final requirements. So and we can achieve that. As I mentioned earlier, we've shipped over 1 million of the EIA racks, and there are no issues with them. So there wouldn't be any issues with these either.
And is the what I forgot what it's called now, the rolling test is with the loaded rolling test, is that done with the braces that we showed in the diagram, or is it done without braces?
No, there's no braces on it. It's done at just as you see in this image here. There's no the braces you're referring to, these braces here. No, we're not using the braces. This is for the seismic bracing, and we did not test that one yet.
I was thinking not so much of the seismic braces, but the horizontal. If you go back to one of the diagrams, you had the breakdown diagram. There's some mid height.
Yeah, this right here.
Those ones.
Yeah, they would. I believe they're. I can't tell from this picture. I would think that they're in there. Now, these are, of course, you've got these shelves in here. These are obviously very strong shelves to support the weight. But I mean, you have to have them. You can't not have them, otherwise you can't do the test. But there's nothing else in here other than what's specified in the bill of material. There's no other braces. There's no other structural support to the rack. And it's just as it is.
In the broken down packaging, I think you mentioned that they were stackable, and you gave a number how many could be stacked.
Yeah. So from the let me see here, from the dimension, where did I put it? Yeah, from this dimension here, you could actually stack up to 7 in a 40-foot container, but we only stack 5. Okay, so we've got 18 stacks of 5. I think that's what it is. 18 stacks of 5 for about 90 racks. And it could be you can put more. I don't, we don't want to really push it. So that's where we stop. We stop at that number. And now, so that's what you would stack in your warehouse too. So we would advise not going over 5 on one. If you have racks in your warehouse, yes, and you can do multiple stacks of 5. But this is a very heavy duty carton material, and then also the wooden pallet as well.
Okay. I think that was great, Steve. Lots of questions there. Thank you for spending the time answering all of that for everyone.
Well, I wish I could have answered all of them a little bit better. I'm sorry I didn't have some of the information, and I apologize about the website. I'll deal with that, and thanks for your patience for working through that. So yeah, if there's any other questions, you can always email me. There's a bit of a time lapse. I'm not usually up at this time every day, but I'll respond promptly. And again, thank you for listening, and thanks to the OCP team for the opportunity. I definitely appreciate it.
No problem at all. Thank you for joining and sharing that with us.
Okay, so I will stop sharing. And
thanks, Steve. Okay, Harry, did you have anything before we wrap up?
No, I think that was it, and I think there was a lot of interesting discussion. Nothing more from my end, Stephen.
Okay, great. Yeah, just a reminder, obviously we got the regional summit in Portugal in April. For anyone that's looking to submit, the abstract deadline is approaching. I think it's towards the end of this month. I don't know the exact date off the top of my head, but please check your emails and make sure that if you are presenting or want to present, you submit your abstracts in time for that deadline. You should all have automated emails from OCP regarding that. Other than that, though, thank you everyone for joining today, and thanks to Steve for what you presented, and we'll speak to you in the next monthly community call. Thanks, everyone.
okay,
Thanks, everyone.
thank you.
Bye.
Bye.